So, hello. Sorry about the slight delay, but I hope that you are well prepared. So, if you still have some setup questions and stuff, we'll have time later when we do the break. So, don't worry about that. Maybe like I explained a little bit, or you have look at the slides. So, sorry about that. My computer just restarted, so it's like weird things going on. The tutorial basically will consist of two parts. I will explain a little bit later. So there will be a lot of information given to you, and then we will do some hand-on exercise. So without further ado, so this is me. Hello, I'm Cheuk. I live in London, so I came all the way. I spent 20 hours traveling yesterday, so fun. So I work for TerminusDB, which is the tool that we try to use a little bit today. But the information, the knowledge that I gave you is not tied to TerminusDB, so I hope you have learned something that is universally useful for you. I just love giving talk to people, and so if you have more questions, feel free to ask me. I was a data scientist, so maybe some of you are data scientists, maybe. Yes, or work with data. You work with data? Yes. Yeah, so I work with data a lot in my previous. I still work with data a lot, so so I'm a Pythonist. I love Python. I love open source software. So you can find me on Twitter. This minor stuff. So in this workshop, we would learn what is a semantic knowledge graph. So this is again, I emphasize again, this is a universal knowledge. It's not tied to TerminusDB. We'll try a little bit of TerminusDB, which is an open source software, but you don't have to use it if you don't like it. But I hope you like it, but if you don't like it, you don't have to use it. Why we store data in a semantic knowledge graph? Why we don't want to use a relational database like we did all the time? So why is it different? And how a knowledge graph is constructed. So there's some building blocks in a knowledge graph that we're going to learn today. If you haven't heard about that before, if you haven't heard about triple, quad, or these crazy wordings, we're going to have a look today. Also, we will do some hand-on exercise. Like I said, we'll try to use TerminusDB a little bit. We'll try to build a knowledge graph schema. We'll try to code in Python, amazing stuff. And we'll try to make some query using the things that we learned today. So these are just technical details. We'll figure it out later. We'll have troubleshoot time, like I said. So everyone can learn this knowledge. It's not tied to Python. Like I said, it's like a universal knowledge. You don't have to learn TerminusDB. You don't have to learn Python. But the knowledge that I gave you today in the knowledge graph, so it's actually anybody can learn about it. But of course, the hand-on exercise will be in Python. So also the setup will be using, using Docker and using Python, or you can use the cloud version if you can't use Docker. So but otherwise, you can just enjoy the lecture. So we're here. I'm just giving a brief introduction. We are slightly delayed, but hopefully we'll have time to catch up later. So there will be a presentation, so around 60 minutes. It depends on how much stuff I'm saying, or like how much question I receive. Feel free to ask questions at any time. I love questions. Then we have a break. We'll try to figure it out, all the setup problems and stuff. Also, get yourself charged, refill your coffee, and then we will start the hands-on exercise, which we will be coding together. Actually, there's a tutorial that already written a while ago, but we'll try to do it step by step together. And if you have questions, you can ask me immediately. So at the end, we'll just have a brief closing, review what we have learned, and how's everybody going, and ask more questions if you want to. So this knowledge graph, right? So there's some kind of keywords that we go through today. We're like learning what is a triple, what is a quad, and then how a graph data model is different from a relational data model. So I always compare them with like, one is 3D, one is 2D. What does that mean? There's also other terms that we use describing things in a knowledge graph, like objects, documents, properties, and other stuff. So we'll explain that. So also we'll look at a use case, kind of, a use case that I make up. So, but through that, you can have build your first knowledge graph. So what is a triple, right? So the triple actually if you kind of talk to someone who loves semantic knowledge graph, you always come across something that's called triple, right? It's a building block of a semantic data model. So lots of times when you go through a semantic data, that you will came across some file format, like some of them is called RDF, some of them is called turtle, TTL, something like that. So they're actually a different file format that we use. So instead of, on the other hand, you have like your relational database, it will be stored in a tabular format, in CSV, in a database, or in Excel, something like that. So, but today we focus on the knowledge graph. So we'll have triple, which we store everything in triple. And triple consists of three main things. So there's a subject, a predicate, and an object. So yeah, it's kind of like remind you of the lesson that you had when you first learned, have your English lesson. Let's say I learned English as a second language. So for me, it's all like the teacher will tell us like how an English sentence is structured, right? You have your noun, your objective, and all this stuff. So it's kind of like that. It's logical. You always have three things. You always have two things like subject and object, and the predicates to describe their relationship. So some example would be apple is red, but it's not like one-to-one equivalent to a language because instead of like apple is red, sometimes you can have multiple kind of word in one, for example, predicate. Because, for example, you have past tense. I don't know why, but apple used to be red. Maybe now it turned black because you haven't eaten it for months. So predicate could not just be a word, right? So it's not a direct one-to-one relationship between a triple and a sentence. But the logic kind of goes the same. So it's kind of like you can construct a complex idea with triples. So here, these examples are very, very simple examples. It's just one idea at a time. So each triple carry one idea. So apple is red. So Cheuk teaches a workshop. And cow loves duck, for example. So this is like kind of kid-like stuff, right? So anybody can come up with some example of triples. Very quiet. Coffee is good? Yes, I agree with that. Anybody else? Python is awesome, of course, yes. So yeah, that's just very simple idea. They are triples. So they are the atoms. They are the most basic things that construct a knowledge graph. So for example, here you can see it's like a kid's bedtime story things, right? So it's like, oh, there's a cow says moo, and then a duck says quack. So, but in this picture, if you want to describe this picture, right? So instead of just one idea at a time, you may have a lot of idea in this picture, right? You can have like, oh, cows had, there's always a cow. So cow has 4 legs, right? So cow will say moo, and then duck, what is duck? Duck has wings, and duck will say quack, things like that. So if you combine all of them together, right, then it will paint the picture. It will construct a more complex idea. That's not just one single idea. So this is world building. This is how we build a knowledge graph. This is how we build a graph that can describe everything in the world, ideally. Of course, we'll come up with some other more complex stuff that will come up, but in theory, you can describe everything by just using a lot of triples. You can build a world with all this triple. So, but we sometimes we have problems, right? What if like I have 2 cows, and they're actually from 2 different farms, right? So they feed different things, and they speak different languages. So one cow says moo, one cow says meow. I don't know why, but yeah. So how can I distinguish these 2 cows from different farms, right? So sometimes a triple is not good enough to distinguish different things. You will see the practical reason why later, but this is what the problem that we have. We have 2 cows. They're both cows. They're not different animals, but they're just from different farm, and they're slightly different. So then how we should solve this problem is to add additional identifier to identify these two farms, right? They should not overlap because they are a different world, okay? For cow, the farm is the whole world, so it's different. So we add one more elements to the triple, so it become a quad. So triple, quad, 3 and 4, straightforward. So now you can compare the two different cows from two different universes, right? Because you can identify them specifically with a quad. So you can cross-reference. You can even cross-reference between the two of them. So that expands the idea of using triple to represent anything. You can not just describe the whole world with many triples. You can even describe the two worlds that is similar but also different, that you can compare them. So why is this good? Because we do that all the time with Git, right? So with Git, you have like two set of codes, but they are slightly different because someone makes some changes and you want to compare them. So by using not just triple but quads, we can also do something like what Git does, which we'll come back later. So that's the basic of what's triple. So is there any questions? It sounds really crazy, or it makes sense? Yes. Quad is just a triple with an extra element or attribute to identify that what graph it sits in. So we can have many triples in one graph, but we can have multiple graphs, and we can compare them. Yes? We haven't go there yet. In theory, you can, but I think because, like at the beginning, right, triple is good enough, right? Like I said, you can link up all the ideas together. But when you do something similar to Git, right, you want to compare the two set of things, then a quad will help. So I haven't think about how we can make it 5 or 6, but yeah. Any more questions? Yes? Sorry, can't really hear. Sorry. Yes, the fourth element is the ID for the graph. So triple lives in a graph. Triple forms a graph. And the last element that we add to a triple is to identify which graph they are in. So yes, kind of ID, but ID for graph. Anything else? Yeah, so in relational database, for example, you have multiple tables, right? So graph is kind of like that in that sense. But how relational database works is different from a graph. Then we will compare about them soon. So yeah. So maybe I will move on. If you have more questions, feel free to ask at any time. So. So in the graph, let's talk about relational database model first. So we are familiar with it. We use it all the time. Even though you are like, oh, I am a Python programmer, I code, but you come across it all the time, right? For example, you use Django. Django use the backend is a relational database, right? No matter you use MySQL or Postgres, they are relational database, or SQL database. Or if you, let's say, oh, I'm a data scientist, I deal with CSVs, they are also tabular format, right? Or if you are like, oh, at work, I use a lot of Google spreadsheet just for administrative stuff, right? So they are all tabular. They're all kind of in the same sense of models. They are all like SQL kind of tabular format of data. So I use CSV a lot in the past when I was a data scientist. Of course, it's not just comma separated. You have some kind of weird stuff. Sometimes you have like, oh, maybe how do you call that character? There's a line. I don't know. Pipe, yeah. So pipe separated values. Sometimes they use different characters, but they are the same, right? So it's also just a file. So the thing is that when you work with them, right, when I used to work with CSVs or the SQL databases, a lot of times what I really struggle with is to do a simple thing, find a simple answer by joining many, many tables together. Sometimes you aggregate and join it back to yourself. So yeah, you can very easily write 1,000 lines of SQL just to get an answer from your data. So that's why sometimes I just want to write a Python program to deal with it, but sometimes it's not possible. I remember when I worked in a company, they have a legacy database, very, very huge. And I can't load them all in Python to find out my answer. I have to use SQL to do the stuff. So not always possible. Sometimes involve a lot of very awkward joins and aggregations that I don't like. Maybe you like it, but I don't like it. So on the other hand, knowledge graph is it sounds a little bit complicated, right? Because relational database is a table, so it's very easy to visualize, right? You look at, there's column, there's rows, you look at it, it's easy to understand. But knowledge graph, I would say, is the 3D because you can link everything. It consists of triples. You can just link things together. It's not limited to rows and columns, which I describe as 2D. You can link it in multi-dimension, not just 3D, but like multi-dimensional, right? So a lot of like common format instead of CSV is stored in this RDF XML format, which is a markup language, so it looks very similar to HTML, but it's not. It's an XML format. It follows some kind of RDF standard. That's why it's called RDF XML. There's this TTL file that the tortoise, sometimes I call it, I don't know, this TTL. Again, it's something that is designed specifically of describing how triple are linked to each other. JSON-LD is what we use in TerminusDB. I would say that's the easiest to use because if you look at XML or TTL, it's just, it looks like HTML, right? A lot of those brackets and stuff is difficult to read with human eyes, but JSON-LD look like a JSON. So JSON is just like, look like a Python dictionary. So it's very easy to look at it, right, for human eyes, until they get too big, right? And until they become too big and the indentation go crazy, then it's difficult to see. So the difference between the knowledge graph and a tabular format or a SQL database is that data is kind of unstructured. Like I said, it's not rows and columns. You can link everything together. Just imagine you have like Legos, right? You can just put them together without any limitations. So it's not really confined to just rows and columns. So it's kind of unstructured if you think about that. I would say that you use triple to paint a new world, paint a new picture. So same with data. You can model your data to work this way. So it's not limited to just rows and columns to describe your data. You can have different, you can just describe the relationship between different things. So how can we do that, right? How can we do that? We'll find out today. So, yes? That's a very good question, because I would say that, because actually, I'll show you later, actually, that you can automatically write a script to convert them, right? Because a knowledge graph is like I said, 3D, so it's more flexible than a relational database. So if you can store things in rows and columns, and maybe multiple tables, you can actually store them in knowledge graph for sure. It's just that how to convert them, right? So how to convert them will require the knowledge of how to model them. That's actually similar to the exercise that we will do later, that how we have a relational database, and then how we can convert them into a knowledge graph. So a knowledge graph is, I would say, is like a bigger set than a relational database. If you can store things in a relational database, you can store it in a knowledge graph. So yeah, that's one of the advantages. It's more flexible. so is the knowledge is very flexible, that you can things you can store in table, you can easily store it in a knowledge graph, no problem. Also, you can actually add some constraint to it. So rather than just free for all, right? You can link anything together. If you kind of build some governing structure on top, which we'll talk about schema later, then you can have a very flexible way structure to store your data. So yeah, so it's so sometimes if you have data that is not very 2D friendly, not good in installing in a tabular format. For example, you have some data that's very nested, or you have a lot of cross-reference. So instead of using some key to refer to each other, you can easily just link them, right? Let's say 2 people, you can link them together, and each people can have their own attribute and stuff. So, that's actually why some people find that a knowledge graph is the only option to store their data, because if they try to flatten it to store it in 2D, all these cross-reference, all this nested format will give them a headache. So that's why it's the best way to do it is to store it in a graph format. Also, if you make queries, like I said, the advantage of doing knowledge graph is that you don't have to join things back together because they are already linked, right? So let's say you have 2 people that is like cross-referencing each other. You just have a link from one object, which is the person, to another person. So you don't have to find the ID and then join them back together. So you kind of like, oh, I know that like now this is related, right? Because they are naturally linked together by the triple, and so it's very naturally works as a graph. So sometimes, it's easier to find the answer you want from the data to just traverse the graph instead of making a lot of joins and connecting everything back together. Because let's say you only need to find the relationship between 2 people. You don't have to join the whole graph of every users that you have, right? Let's say you have users and you just want to know that, oh, who referenced this user, instead of you have to do a lookup, which look at everything. You can just like traverse the graph because they're already linked together. Who are the referencee? You can just, found that person. So yeah, so that's sometimes it's better. So I know that recently, or in the last few years, data lake is a big hype, right? You can a lot of different cloud service is providing data lake that you can store a lot of things in it. It's just referenced by a link, so you can have a blob that put in the data lake, and you just find the link to that blob of things. So it's like a lake, right? Everything can put it in. So the advantage of that, but sometimes we want structured. So with a knowledge graph, you can add a schema on top, then you have structure. Then you can find the things you dumped in the data lake much easier, rather than just have a bunch of links, you don't know what they are. But with a schema, it will help you to find important information from your graph. So how do we do that? A schema is needed when you have cases that, for example, you want to monitor what data come into your graph. You need, so like a graph, like I said, like naturally, a graph you can just link all the triple together and build something, right? But sometimes you don't want that. Sometimes you want to have a structure that, for example, a person always have a name, let's say, with first name, last name, but it's a bad model because some people only got one name, but anyway. So let's say a person need to have a name. Let's say a person need to have a contact number, because if we can't contact them, they don't exist in our database. So you can build a schema, a structure to govern how your data look like. For example, contact number need to be digits, right? Let's say contact number need to be only digits. Let's say it's a bad model, a bad example, but let's say you design it that way. Or a person's name can't have emoji on it, something like that. So you can actually, having a schema, you can governance, like how your data will look like. You can't just have anything that just come in. You need to confine to a certain format to be in your graph. So that's what schema is for, and that's why it's useful most of the time. So I'm using TerminusDB as an example here, but generally you have similar design for graphs to be useful, to be honest, yeah. Because you have objects, first of all. You have a lot of objects in it, right? Even though you can describe anything with triples, but to make things more systematic in the schema, you will have objects, right? So it's kind of like Python, everything is an object. So you also need to have, objects in your graph. So just like Python objects, they also will have properties. They can. So another object can be their property. So it's like you can build anything with it. Also, there's like documents. So documents and objects, they are very tricky. They are basically the same thing, but documents. So how we design it is that document will have an ID, object don't have an ID. So later we rename it into subdocuments, and it just go into more like kind of crazy terminology. But just imagine they're the same thing. Sometimes I use the word interchangeably, like objects and documents. But just remember, documents always have an ID, objects doesn't. Enums. So enums is it's also very useful. Well, we're all familiar with it, but yeah. So yeah, more details. So objects is we're not alien with it, right? Because Python naturally, like you would already come across object-oriented programming if you use Python, and so you can create so if you think about an object in a schema or document in a schema, that is like a class, right? So you can create instance of it. So so that's how I see it, is that a documents or objects in a schema is the class. And then the data you put it in is the instance of it, right? Again, like I said, objects as a document, they don't have an ID. Documents, they have an ID. It's just funny naming things. So later we'll see the example there that I would have a person have an address. So in an address, we just gather all the street numbers, a postcode or zip code, city, town, county, all this stuff like into one package. So address will be an object with a lot of different properties of all those things. So or attributes in Python, there are attributes, but it could be properties. So just different naming, right? So so you can also put this address as an object itself into different things. For example, you have different users, or you have one user, they can have different address, or different users can share the same address. So you can also reference it to another object as well. So yeah, document is just again having an ID. The reason why we made this difference, because sometimes you just want, for example, the address that I mentioned, you just let's say two different users can't have the same address. You design it this way, don't ask why. So an address always live inside a user, right? Live inside a person. Then you don't have to cross-reference it, and it's just a package of stuff. But a document will be, let's say, different users. They will have to have an ID, so you can identify them. So you can find out who they are. So you can cross-reference each other. For example, one user is referring the other user, so they both get a discount or something like that. So you may want that. You need to use an ID to identify them. So each of them will have a unique ID. So that's the only difference, really. It just makes things a little bit different when it works in the graph. So very confusingly, we also have different naming issues, but that's how we name it. So there's ID, which is a unique identifier. Try to ignore the one before the slash, because I put it there because the old version used the old naming, which is on the left, but we're focusing the one on the right of the slash. So ID is the unique identifier, just like a key, a primary key. A name is a human-readable name. So you can use emoji in there. So has anybody tried to import something as emoji, right? So my friend has tried import pandas as panda emoji. So yeah, you can use emoji in there. It's just, or sometimes let's say ID, you need to be confined, because like because of how we store stuff, so ID need to be, let's say, what's that, like URL safe. But name, you know, sometimes people's name will have those accent. So then the ID doesn't reflect the name correctly. So you may want to store the name as a different thing. So it could be any string as a name, and then you have a longer description and stuff. So that's how all the documents we make it work like that. And so again, it's just like an example how a document works in TerminusDB. But I think that's a really good model, because yeah, you will need an ID and a name and description. Just like, you know, every talk, right? Imagine like a lot of things are like that. Like, let's say you have submit a proposal to a conference, right? You have an idea of your talk, and then you have the title of your talk and your abstract of your talk. So a lot of things work like that. So that's why it's kind of like that in TerminusDB. Of course, you can add more properties in there. So these three are the defaults. You can add more properties in there. For example, like I said, the proposal you submit is to a conference, then you may want to have other things, right? You may have the duration or the type of this proposal, or you know, you may want to add your bio in there as well. I don't know. So it will have more stuff, but the basics are there. So enum is just like enum in SQL or enum in Python. It's just a list of values. So a lot of times, you know, we need to use enum because we want to limit the choice of what people has. Like if you fill in a form, right? A lot of times you came across a drop-down menu of choosing things. For example, which country you're from. So there's a lot of different countries you can choose. Things like that. So. Any confusion about documents, objects, and enums? So there are the three different things that we will have when build our schema. We will basically just creating these three types of things. We'll create an enum, we'll create a document, we'll create an object or subdocument. Yes? A document is the object itself, but with an ID. Yes, I know it's very confusing, so that's why I want to pause and see if people are clear about that. Yeah. Okay. Everything is an object except enum, which is just a list of choice, which that's why it's structured a little bit different. So it's kind of like, is that Python? So it's like, let's say Python classes and Python name triple kind of thing. Like it's just a different things, but yeah. So for the objects, right, or documents, they will have properties. So the property itself. So this is actually when we do hands-on exercise. This is not going to. We won't use this information. But I'm giving this to you again because this is how when someone describes a semantic graph, sometimes they describe things this way. So that's why I give you extra information to understand it. But in our exercise, we won't use this, just to warn you. So if you think it's complicated, don't worry, we won't touch this. So properties. So far, how we look at things, right? It's like, oh, I have an object and I have a relationship and another object. Let's say I'm my mother's daughter, right? So my mother, give birth to me, let's say. So there's like three kind of things, triple relationship, all this stuff. But now we want to look at it differently. So look at, okay, so there's a relationship. Okay, so my mother, me, relationship. So look at the relationship itself. So we will look at the two ends of it, right? So it's kind of like that property. Let me think of a better example. So let's say I am the object. So I have an ID, right? So my ID is 001 because I'm the first person that I created in the graph. And then name will be my name, right? Cheuk, okay? That's usually how we look at things. So there's a thing, and then property, and then there will be name will be Cheuk. Cheuk is a string, right? But sometimes we want to look at things a little bit different. We look at the property itself. So we look at name. Okay, so name is a property. But a name will also have a domain and a range. So what is that? So name is a property of a person. So that's why name's domain is a person. Okay, it's a person object. And the name's range would be a string because it stores a string. So it's kind of like a property-centric way of looking at things. Instead of looking at, name is a property, is of a person, which name will be, very passive. But now I look at name actively. So what is name's domain? Is person, because it belongs to person. And its range will be a string because it stores a string. So we already talked about that. We mainly just look at person. We have a property name that stores a string, right? So it's the other way around. But sometimes we mention domain and range, and that's what we mean. So sometimes range can be another person. Let's say later you see in the examples that we have a lot of employees, and they will have managers. So you can have employee, and then manager will be another employee, right? Because your manager is another employee. So range could be another object. So it could be not just a string or number or any data type. So it comes to two things. So it's make it more complicated, right? So it's there's the data property or object properties. So a data property means that things are just data. How can I describe it? So they are just, we call them data types. It's just text, like string, or it's just numbers, like integer or decimal, or they are booleans. You can be more complicated, like unsigned type, the unsigned integer or something like that. But they are not another object. That's why they are called data types. They are sometimes literal data types because they're literal. They are just what they are. They are not another object. Well, of course, you can say in Python, string is also another object and integer is another object. Well, not in our case here. That string is just like text. Okay, it's not another object. So object property, on the other hand, is another object. So for example, like I just described, so employee is a object, So if the range of that property is another object, then it's an object property. So you can think of it as a link between two different objects. It could be not just employees. It could be like someone, let's say a user, has the billing address. So, but you make billing address is an address object. So you have user and address, two different objects. You link them together because this is the billing address is the property of the user. So billing address, we have a domain of user and a range of an address. So, okay, hands up, yes. Data about the relationship. So that you would have to think about what this data mean, because so you can also, for example, we have the billing address thing again, right? So you could, how can I describe this billing address that is a billing address that is not a residential address, let's say, or how can I have a property for this billing address, but not just how can I describe it? Is that what you mean? That describing the relationship? Yeah, so in this case, this link, right, is a property. So it really it only makes sense when it belongs to the user, right? If the billing address doesn't make any sense if it does not belong to a user, because it's a property of the user. Is that? So yeah, in this case, it's not bidirectional because the domain and the range is obviously two sides of the thing. So you can't have the other way around. So you can't have well, if you want to go back in the other direction, let's say you have the address and then who this address belongs to, then you may have to add a property for the address to link it back to the user. So yeah, but by nature, the properties, the link between the object properties, they are one directional only, because they have one side which is domain and the other side which is the range. So it's not bidirectional. Yeah. So, wow, it's information overload. How can we do this? How can we represent data in a knowledge graph? So let's say we have a case now, a case study now. So in the next slides, I will give you an example of things that I've made up. Okay, it's a database in a tabular format, and then we could try to create a schema, so to model it into a knowledge graph. So it's governance by the schema, so that's why we build a schema, and then also in the exercise we will try to put the data in it as well. So it'll be nice. So don't worry. I know that there's a lot of information. It may be your first time thinking that way for data, but we'll do it step by step and slowly. So, for example, I hope it's clear enough. Otherwise, you can refer to your notes. I have made up this is a small company, a small startup company, only 4 people working there at the moment. So it's a phone book. It's a phone book database. So I've made it very, very simple. All these data are fabricated and generated randomly, so don't ask me why I have all these names. They're just generated, so I don't even know. So there are 4 employees, and then they will have their name, their title, and then which team they belong to, and the manager. So this table is describing the whole company structure, right? But there's no personal information in there because they are sensitive. We only allow, let's say, the certain people to access it. So we store it separately. So this is another spreadsheet or database or whatever that store the contact details of the employee, right? So they have the ID because we need to link them back together. Joins, we love joins, okay? And contacts numbers, and then home address, and then postcode and stuff. So yeah, this is a relational database, and there's 2 tables. You can imagine they are just 2 tables in your database, and they have the primary key, which is the employee ID. They should be unique. So yeah. So let's start modeling. So what we'll do now, we'll try to design the schema together first, and then later when we code, we would put that really into practice. But to make things simple, we will just decide on some design first. So documents. So documents. What would be our documents in this case? So what would be the main things that has an ID in our graph? Anybody want to try? Well, I know you have the slides, but yeah. So that would be obviously employee. Yes, I heard it. Yeah, so employee will have an ID, so naturally there would be objects or documents that has an ID, right? So okay, good. We have employees. Okay, so now we have to populate the information about them, right? So they will have properties. So what properties do we want to have? So of course they will have a name, and then they will have the title, and then the team. So team, we only have 2 teams right now. So maybe make it an enum. Yeah, that makes sense. And they have a manager, and then now we have object properties. I can link employees together. Yay! So we have all these cases. And then to make it more tidy, we can get all the address or the contact detail into one thing, right? We can have the address, even break it smaller, we can have the town. So this is still very British. The towns. Yeah, the postcode is also British, I know, because I live in the UK. So yeah, you have let's say the street number and the street name, the town, and the postcode. So we can tidy them up into one subdocument or object. Is address. So yes, let's work it this way. So this is the summary of what we would do. So you can see the thinking process behind it, right? So first you decide on what will be the object, and then what would be the property. Sometimes it's help to gather some property together into some subdocuments. So that's how we do it. So name, just a string. Simple title, just a string. Simple name, you can also try to break it down into first name, second name, whatever, but because name is a very tricky thing if you have seen my tweet or something about name. So let's not make it complicated and just have name. And then team, it will be enum, so just 2 team right now. Managers, there will be object property. And then contact number, little type, so just, I will start a string because we have the crazy bracket there, so just a string. And then home address, we make them nice into an address object or address subdocument, and then postcode, I'll put that into address as well. So, employee ID. So okay, here's the caveat. I think I've changed my mind a little bit here when I designed the exercise. So actually, it's not necessarily to give them the ID, like 001, 002, all those stuff, because if you put a document into TerminusDB, TerminusDB will see, oh, you haven't given an ID to the document, I'll give one for you. So just randomly create it, or you can actually tell TerminusDB how to create an ID for it. But I think in the exercise, I want to make things more simple. I just create an ID for them to make things easier. But it's not necessarily. But I won't spend too much time into ID because it could be a lot of other, sidetracks and stuff. So I'm not going to sidetrack myself too much. Yes? Yeah, so you're talking about, what if I insert the first person twice, right? So how can I make sure that is unique? So so what happened is that in TerminusDB, so I just said that, if you insert a document, it will just generate an ID for you. So if you insert the same document twice without an ID, so I'm talking about like when you're actually coding and do the stuff that we are doing later, then it will just treat as 2 things. If you don't give it a unique ID, then you just, you have inserted the same set of things twice, so I'll just treat them as 2 separate things. So there will be 2 person with the same name, same title, same credential and stuff, which may not be something that you want. But if you give them an ID, give them a unique ID, for example, let's say I hard-code it as 001, 002, 003. They would just be like the relational database, the primary key. If you insert the same ID twice, then there will be an error. You have to tell TerminusDB that, I'm replacing it or I'm updating it. Then it will update it. Otherwise, it will be like, you can't insert the same things with the same ID twice. So in TerminusDB, you can also say like, I don't want to hard code it. I don't want to make it random. You can find a middle ground of like, can I use the name as the unique identifier, so generate an ID using the name, something like that. Exactly. Yes, you have to create a unique identifier. So, yeah, if you don't specify it, TerminusDB will just generate one randomly for you, and it will be ensure that it will be unique. But for example, you're migrating your database. You need to find what is the key, what is the unique identifier, and then use that as the ID. So, yeah, so that's why you see it when we code. Okay. Yes, you can. So I don't want to drive into detail, but actually, yes, you can have, so there are different ways of how you can generate an ID. So I've mentioned 2. One is hard coding it. Every object, you give it an ID. The other way is randomly, but there are also other ways, like this one that's called, Yeah. 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 So wait a second. Let me answer that question. So you can combine different things. So there's literal things that you could have not just one field, not just the name. Let's say you need the name and the title to be unique. So you can be like name and title, and it will generate a unique ID based on the name plus the title, right? You can have them combine. So for the second question, that you need to have, so if you insert the same document with the same ID, you will have an error if you use insert. So what if I want to change things for something that I already know, that I already inserted before, I want to change it? Then you have to replace it. You have to use replace. So you can't mix up the two operation. You can, in the Python client, I added some function that it will check whether it already exists. If it does, then it will replace it. If not, then it will just insert it. But in the raw design, you can't mix up the insert and the replace. So if you insert the same thing twice, it will have an error. If you want to update something, you have to use replace. Yeah. Okay. So yeah, I've talked a lot about like how TerminusDB work. So TerminusDB again is open source. So everybody can get it for free on Docker. It will be open source forever. That's what my my boss told me. So the founder said that like it will be open source forever. You can always just download it and use it for free, or build from source if someone is if you are very if you're tech savvy enough to build from source, you can do that. Source code open. Okay, so it will have some feature that you may like, like revision control. If you like it, you may like it. Also, we try to create a cloud version which you can easily collaborate to share a database within two people, like GitHub, that you can share a repo between people. You can like see whether they can merge something. There's a lot of kind of roles that you can give them, what access level they have. So that's what the idea of what we want to achieve for revisional control and the collaboration. So open source, I think I don't have to explain it. We all love open source. We know what is open source. It means that the source code is up in the open. It's for the community. The license is Apache 2, I think. So it doesn't mean that you can do it wherever. You have to follow the license, but it generally is, it's a very common open source license. So it's not something different. Yes, so for Neo4j, Neo4j works a little bit differently from what we are. So I don't have a benchmark like-to-like comparison. Maybe my colleague has done it in the past, but we have improved it over the past few months. So the answer is I don't have a good answer for that. Yeah. Also, graph database, like you just mentioned, there are other graph database in the market, Neo4j and stuff, but we just work slightly differently. Choose your own adventure. I'm not trying to say that you must use TerminusDB, but there are a few things that we are different from Neo4j. Let's say Neo4j, the query language is Cypher, so it's a text-based query language. We use JSON LD, so it's a JSON format. So we think that JSON is better because you can't inject tag it. So that's one thing. So also we try to do revision control. I know that MongoDB can't do revision control, so so that's why we try to do have some way that you can actually do this comparison with MongoDB as well. So yeah, so we're just trying to build more feature for people to use. If you think a feature is very important for you, talk to me, and we'll see how we can help. So other things, we have this document API. So we found that. So after a few years of development and then experimentation, inserting data as triple is quite tricky, especially when you have a schema. So we built this document API we call. So it's kind of like you can build a schema more in an object-oriented programming style instead of writing triples. But we also try a little bit of triple things at the end. But that would be a query, not as inserting data. So there's Python client, proudly maintained by me. So if you find any bugs, you can complain to me. So we used to have these graph representation in D3. It's very nice, but we have put it down for a bit, and then hopefully we're coming back up again. So I won't talk too much about it because it doesn't exist anymore. So TerminusDB is on Docker Hub. I hope that you can get the image or just have one version of TerminusDB, the latest version of TerminusDB, working in your computer. If you don't, the workaround will be signing up on Terminus X in terminusdb.com. So that's the cloud version. Right now, we are not charging. We are still letting people to try and test it. So I can't say for what the future will be like, but right now it's free. That's what I can tell you. So there are 2 clients that's working. Python client we'll be using today, JavaScript client. If you are building web app, you may be interested in that, but that would be another time. So we're back to here. I'll let everybody to take a break. I'm still bad with time. Let's say we take, how much time do you think we need? I don't think we need 20 minutes, right? Let's say 15 minutes max. Then we'll come back, and then we will try to do some coding stuff. If you are struggling with getting either the Python client or the TerminusDB running, then let me know. I'll try to help. Any other questions? Also, let me know. I'll try to help. Otherwise, I think, let's say now it's 40 past 2 or 20 to 3. Let's come back at 5 to 3 p.m. Okay? Yeah. Okay, hello. Okay. Well, it's a bit small to see and difficult to see, isn't it? Sorry about that. Just shout if you think this too small and it's yeah, things like that. Because I need to find a right balance that I can see what I'm doing, but at the same time you can see what I'm doing. So let's put this away. This is not what I'm doing right now, I think. I may need some help there, but that's later. Okay, so let's zoom this in as well. So it's awful. Okay, we adjust it when we're using that. So let's come here. If you go to the tutorial slices, I would just see. Yeah, so I hope everybody's fine. I know some of you have some issues with that. I'm so sorry if you really can't get it set up today. I'm so sorry, but all the information is given to you. So if you want to try it at home, feel free to. And if you have questions later, you can also contact me. Happy to answer. So I hope you also have the Python client installed. And I'm using Poetry as well. So also advertising for Poetry. I really like that tool. Recently converted to it. I was using the PyEnv virtual env before, but now I fall in love with Poetry because it's nice. So I hope everybody's okay with the setup. Like I said, if you really struggle or something, everything is hosted online, so you can catch up or follow or do the lesson that I didn't cover today by yourself at home as well. I'm happy to answer questions. Just give me a shout online or something, or you can join the Discord and talk to the team. Sometimes they have better answers than me because they know inside out of the database. So we are going to use this getting started tutorial. So we have developed a lot of tutorials. Not all of them are my work. Some of them are my colleagues' work. But we're focusing on the Python client getting started tutorial there. It should be working. The link, if you click on it, should go to this page. And then we are focusing on lesson 1, 3, and 7. There are more than that in this. Again, feel free to try everything at home. But I don't think we have time to go through 7 lessons. So, we're focusing on 1, 3, and 7. Also, one thing before we start, all the codes are actually available in the repo, but you don't have to clone the whole thing. All you need is the 2 CSV. These 2, the contact and employee CSV, but they're very small. Even though you can't clone it, you can just copy and then paste it in the text file and rename it the same thing as I did here. That's all you need. And And then we'll do things step by step. Even though the code is available, I would recommend you try it yourself or do it differently. Because it feels better if you make it work by yourself, right? Rather than copy and pasting. The code here is just for me to cheat when I'm struggling, because live coding always have accident and it doesn't work sometimes. Then I can cheat by using the code that I've written before. But I highly recommend you to not copy and paste and try to write your own code. If you're really struggling, yes, of course you can do what I did, copy and paste. But yeah, let's look at it. So first thing. Again, so what we're gonna do here for lesson 1, 3, and 7 is to create a schema, like we talk about in the slides. So we'll actually go back to the slides when we create a schema. We'll use what we have designed as the blueprint. So we'll follow that and how to convert it into code and make it work. We'll do that, and then we would also try to insert data. How you can have the CSV and do some data. Handling, to make it into the database, and see how Python client make everything work as an object. So that's what lesson 3. And then lesson 7 is actually the fun bit that we would try to make some query using triples. So triple. We learned triple today. We want to use it, so that's why we are doing that. So right now, go to start a new. So you can start it in a new directory. So you will have things like that. Oh, sorry about everything that I have here. I was testing it before, so that's why I have so many things. It's still a bit small. Why is it so small? Please. Is it big enough? Or is it not good? I don't know. Also, it's dark mode, so give me a shout if it's too small for you. For those at the back, you may struggle a little bit, but let me know if you want me to make it bigger. So I'm using poetry, so this is my poetry shelf. So I have TerminusDB installed. If I do a pip list, you'll see there's a bunch of things. So what we have is the TerminusDB here. Oh, where is it? Yeah, TerminusDB client. So I'm good to go. I think I have it. Yes. And then I'm also clearing it again. So I'm in a new directory, so I have, it's not really new for me. So I use poetry, that's why I have the poetry log and the PyProject.toml. So it doesn't really matter for the substance in the PyProject.toml, but what is vendor? I don't know what is vendor. I don't know why it's there. But anyway, I have the 2 CSVs there. That is just the CSV I showed you before. You can find that in the tutorial repo. So it's just this, right? I have them, but otherwise I haven't done anything. Imagine I haven't done anything else, right? I just have poetry, I got the thing installed, I have just copied the CSV, so this is how I start. So also one other thing, I have my Docker running. So if I do Docker, this is so small, but this is not important, so I won't make it too big. So Docker PS, it should show me that it's running. Yeah, I have my container running, so all good. Right. So I would demonstrate it with the local image. So if zoom in a bit. Yeah, sure. Okay. Is it better? Yeah, I'll clear it as well. So you go back to the top. I'm using it locally, the Docker container. If you're using Terminus X, it will be a little bit different when you connect to Terminus X. I would also explain it, but I'm using the local one. So okay, so first start, we would have. So when you install the Python client, there is the TerminusDB command should be up. Typing with one hand is very difficult. So the command will be available to you, TerminusDB. So I built it using Click, for those of you who are interested. So there's a bunch of commands that you could do. They kind of basically help you to work with your database. But before that, you have the start project. So you see there's a start project. It's kind of similar to Django, right? I got the design from there. But yeah, start project makes you have to set it up how, for this project, it connects to the database. So that's why you start the project and store the configuration there. So if you do start project, So I hope this also complete, but I'm not sure. Okay, so if you just start project, it will ask you a bunch of things. So a project name. So you can do it anything, but remember this name because you use it again when you use it in the script to connect to the database. So I will call it workshop maybe. Yes, and then okay, here is when it got different if you're using Terminus X. So if you're just using locally, you can just press enter and that's it for you. But for those of you who are using Terminus X, let's see if I can demonstrate it with my Terminus X. So, sorry, it should be dashboard. Yeah, I hope I have logged in before. I don't know, I'm not so sure. Oh, I haven't logged in, but I can just logged in, yes. Right, it's very small, right? So if you're using Terminus X, I have other things, don't worry about that. And I should be in this one as well. Okay, so I have other things, don't worry about that. But what you can do is like you will see something like that, not my Bitwarden, sorry about that. So you'll see something like that, right, if you're using Terminus X. So you can go to your profile and then you will see how you can connect to it. So now when you ask here, can you see the last line there? Yeah, when you ask like, oh, what's your endpoint location? You just have to copy this one. This is your endpoint location. There, I think without the team name, just until .com, right? Just the domain there. So clouds.terminusdb.com, and that's your endpoint location. And then you would also ask other questions like what is team? So when you asked about the team, so the team will be the team you set up here. So this will be a team. It will be different from yours, but just look for the team and then put the team there. And then also it will ask whether you want to set up your API key. You can either set it up yourself in your console like this, or other means. I know someone just set it up with Python. So you can say like, oh no, I don't need to set it up. Or you can just say yes and then set it up by generating an API key and put it there. Okay. So if you have any struggle using Terminus X to connect, then let me know. I'll try to troubleshoot while I go. But for me, I use it locally, just enter. It's the easiest way to do it. So now, if you look at, so I use Atom. So sorry about that if you don't like Atom. I'm using Atom. I don't care what you think about Atom, but I'm using it. You can use other things, right? I'm not saying you have to use Atom. So in your project, you should now have this config.json file. So you have the name of your database, your endpoint, and your team. If you have, you have a different thing if you're using it, the Terminus X, the endpoint, and the team. I think it will also maybe ask about your login or something. Just answer the questions by grabbing the information you have on the dashboard. So you have something similar to this, okay? Also, you have a schema. So this is, like the title said, this is an example. This is not a schema that we're using today, right? Just a bunch of other things. But we'll start from here because it demonstrates how a schema should kind of look like. So you see that we'll have to import the certain things because all the objects are actually all the documents, including the subdocuments, which is objects, they are inherited from the document template. So. And also all the enums are inherited from the enum templates. So for the hash key and tag union, we are not using them today, I think, so we can just ignore them by deleting them. So, yes, question? Waco is, history of a Waco. So we designed this query language called Waco, which we'll try a little bit at lesson 7. But it's a very silly naming mistake that we made. We just call everything Waco at the beginning. So it's just like everything starts with a Waco here. But even though they're not related to the Waco query. It's just a stupid name. Sorry about that. Sorry, you have to type 4 characters. But anyway, I wish I would rename it one day, but it's still work in progress. So So here you can see the example of how, so I'll go through this example first and then we'll build our own. So you can see how we can declare a document class. So this is not an actual document object because we are building the schema. The schema is kind of like I said before, this is the class, right? And then the document itself would be the instance. This is just the schema, is describing how things will look like. So that's why it's a class. So so this is a country class. It inherits from document template, and then here you can add the doc string here, which will be used as a explanation. So remember all this stuff they have. I talk about all the documents. They will have an ID, they will have a name, and then they will have a description. So this is the name of this class will be this, and then this is the description. And then all these attributes will actually add the attribute to these properties. So it's just documentation, right? I won't go through too much detail in it. It's just how you can actually document it just like you document your doc string. So this is very familiar for me because it's just like NumPy documentation. So this is how. Oh, you can also document the whole the schema as well. But again, like this is you can change it, but it doesn't matter too much how things function. It's just a good practice to document things. So here is how we make the key of the document work. So the thing is that we set an underscore key here. It needs to be the key object that we kind of, oh, I just deleted it. But yeah, it's a key object that we need to get from here. So this one won't work now because I just deleted the hash key. And hash keys just means that use the name field. So this is how we kind of do tell TerminusDB how to generate the key, right? We won't make the example too complicated, so we won't mess with the hash key or the literal, is that called literal key? I think it's called, I can't remember, but there's different keys that you can use. But we just hard code the key here for the document, so we won't play with this setting. But if you're interested, you can find all this information in the documentation. So this is basically saying that, oh, use the name field and then generate a hash key based on that. So, but we are not doing that. So. We'll delete it anyway, so let's leave it be. So name is a property of that thing, which is a country, and is a string. So it is how we is kind of making some attribute and then using the typing to tell to create the schema. So also if it's a list of string, you can do it this with list. So this is just typing. If you know how to do typing in Python, this is just how you do it. That's typing. Okay, so if you're new to typing, don't worry about it too much. You can just copy the example. But if you know typing, this is just typing. So how to make a subdocument? A subdocument is well, this is black doing this for me because this is too long. But subdocument is just you can basically just do this. Let me make it easier. You just do this. You just add an empty list to a attribute called underscore subdocument. That's how you make this document a subdocument. So this one won't have an ID. You don't have to worry about ID of an object of the address because you make it a subdocument. It shouldn't have an ID. Okay, and it needs to always live within the document as well. Yeah. So so this is again showing how you can reference another. So person can link to a person. So this is an object property. So this is just like typing. I'm setting that friends of need to be a set of person. Okay. Anything else I want to tell you? Oh, maybe enum. So you can also do other more complicated things like inherit location from address and coordinate, but we won't go into the detail here. So tag union, I want to show this. Yeah, forget about tag union. We won't go through it. So enum is that you just need to. So this is just a like a Python enum. That's how you do it. It just works slightly differently than the Python enum because we have created this custom enum template. It just have some inner working that when we push it to TerminusDB, it will do something. But it's just like making your Python enum So it's just like that. Yeah. So let's start working on our thing. So let's go back to our blueprint, right? I talk about the blueprint. The blueprint, where is it? I think somewhere here. Yeah. So this is how we're gonna based on this page, we're gonna build a schema. So first of all, we need an employee object. So let's go back to our schema. And okay, so we already have an employee object, but we don't want it like this, so it's got to be different. So let's start from scratch. Let me try to delete all this stuff. So is it okay if I don't use a mic? Yeah, because it will free my hand and I can talk at the same time. So we have employee, right? So it needs to be a document template. So you put it there. And this, okay, so like I said, we don't have to worry about the key because we are not, we are hard-coded ID, so to make things more simple. But we need to put all the property in. So what property do we have? We have a name, right? So the name will be a string. So this is how you do it. Just name will be a string. You can also make some doc string here if you want to, but I won't bother with it at the moment. So name, what else do we have? We have the title, right? Contact number. Contact number, yes. Yes, but do we, oh yeah, contact number is a string, you're right. No, we like that. Yep, and then, what else do we have? We have address, okay. Address is interesting because address will be an address object. Just like that, because we haven't made the address class yet, that's why we need the quotation, right? So in general, I just add quotation to everything because I can't remember like where I put the stuff. So what else do we have? We have so postcode will belongs to address, we have the manager and the team. So team would be a enum of teams. Again, I haven't created that yet. And then also manager would be another employee, right? Kind of like that. Sorry? Can't hear? Yeah, I'm changing that. Yeah, this is the file that I generated. I deleted all the other stuff. You can see that. Huh? Yeah, it has, but it will be different. So I would rather start from scratch. Yeah.
On the in the thing, you have optional for the manager.
Yes, correct. I oversee it, and thank you for reminding me. So optional means that because if you look at the table, right? If you look at the table, some of them don't have a manager because the manager doesn't have a manager, right? Yes, I remember the first employee, not this one. Oh. First employee, yeah. So Dynasty doesn't have a manager because she's the manager herself. So, so we will make it optional. Otherwise, when we created the schema and then when we insert Destiny in it, then we have a problem because we are expecting Destiny to have a manager, which she doesn't have. So we have to make it optional to give it so it can be a missing data, right? So it's kind of like, remember, every data scientist nightmare, missing data. So optional, just make it like, oh, it's okay to be NA. It's okay to be missing. That's basically what it is. So address. Okay, let's move on. The address is also a document template. Any questions? Is that it? Okay. Yeah. So addressed is also a document template, but this one is different because it's a subdocument. So just make it like that. Oh, sorry for typos. Sub-documents. Okay, and then address will have a bunch of things. We have, I forgot how I designed it. I think we have a street number or something like that. Yep, postcode. So street number, I think I have made it an integer or something. Yes. Don't worry, I would copy and paste at the end. I would make it neat at the end, so we can make mistake now. It's fine. It's fine. Street name maybe. STR, and then postcode. Yes. will be a string because there's this UK postcode, there's other letters in it. We also have a, can't remember, town, maybe town, let's say town, I don't know. And then I think that's it. Yeah, it's fine. Like I said, I would cheat at the end because I want the demo to work. So it's okay to make mistakes. It's okay. So the next one is enum. So we have the team. So we have to create a team. So team would be a enum template. Whew. Lots of stuff. So we only have 2 teams of marketing. And then you can just do it like that to make it simple. Yeah, because we don't have a value actually, we just have 2 options. So, I think that's it for this. So, yeah, it should work, but like I said, I would cheat a little bit. You don't have to, but you're also welcome to cheat. After you have created it, then you can actually maybe check against the one that I've created in the tutorial.
So could you show how you did the team again?
Oh, team is enum template. You just, instead of document template, you have to use enum template. And then when you do that, it's just like you can just, so there will be 2 options here now. It will be marketing and IT. You can just assign a empty triple to it because, well, normally when you do enum, you assign a value, but we don't have a value, so you can do it like that.
Can't you just make it like the string version of could I say marketing, then you say equals marketing is the string?
Yeah, I did that in the example, and then I realized that it's more efficient to do it this way when I insert the data, so I just do it like that. Yeah, because otherwise I don't have to fiddle around with the underscore, this blank space become underscore, this stuff, which make it more complicated. Because I think when you have the value, it has to be, it will, internally it will do something with it, so it's a bit crazy. So yeah. Yeah, I think that's more or less what we do for the example. Let me see if I can dig up the example here. So let me have a look. Okay, schema the pie. This is the one that I already did. So you see, this is, I have more time to make it nicer, so it look like that. Also typing, we only use optional here, okay. You can also document everything if you want to. So the thing about it is like we won't have this employee from CSV. This is generated from lesson 2 or something, so we won't need it. So we just copy from the team. So we just copy the 3 objects that we have. Okay, let's copy this so I can make sure that it works. Yeah, like that. Also, I don't need list and set. It doesn't matter, but if you like black it, it will just correct it for you. I love using black. It just make it so nice. But yeah. Anyway, it's fine. It's just you just have to make it work. So yeah, you can check against again. Like you can check your the one you just written with the model answer. You can, if you are confident, you can just move on. Otherwise, you can just copy it to make sure that it works. But yeah. I'm just not very confident about my own coding, but yeah. Okay, so now we have created a schema. Make sure you save. Okay, save, double check. Okay, so but it's not there yet. We just saved the text file. It's just a text file, right? How can we put it to TerminusDB? So I have created this very, very handy command called commit here. So now go back to this terminal, whatever that you're doing. So TerminusDB, I'll type it correctly. So use commit. So this one will just get what you have in the schema.py and put it as a schema for your database, right? So this is, again, like this thing we internally in my company, we call it a scaffolding tool because everything is just done for you. Yeah, like you can do it yourself with a Python script as well, but it's just easier if you do it like this. So also you can add a commit message, like let's say create schema, something like that. You can add a commit message as well. So when you do this, please work. Yes, so you can see the workshop, the database is named workshop, right? Workshop is created, workshop schema is updated. So now, if you check, if you type TerminusDB log, you will see that now we have created schema, okay? So yeah, this scaffolding tool also make it more Git-like, so you can do things like that to check. Because for the Docker image, we don't have the web interface like Terminus X. Terminus X, you can also check it on Terminus X if you're using Terminus X. For example, do I have it here? Yeah. For example, I go to a random repo that I created before. I can look at you can see all the commit message here. You can see what's inside, right? So, but if you're using Terminus X, you can check this. You see a very nice graph here. But if you're not using, it's fine. We can just use the command line. It works well. Where was it? You just use the command line. It works well. It's fine. Yeah. Sometimes I prefer the command line rather than the web interface. So that's our.
What was the command line?
Sorry,
Can you show your command line again?
You mean the command, the commit command?
Whatever you did at the very end. Was it log that you?
Oh yeah, log. Yes, TerminusDB log.
So the commit is minus sign.
Sorry? Yeah, it's pushing the schema it's committing the schema only. Yeah, you can also update it. If I made a mistake, you can change it. You can commit again, then we change it.
Can I ask a question? This concept of like branching and merging and so forth, is this to allow what would traditionally in RDS in a relational data schema migrations?
So you mean like all these branching and things? Does it work with the
What's
schema?
the purpose of that? Is it to allow for schema migrations?
Yeah, so those things are something like we call it Git-like kind of revision control thing. So what happened is that, for example, I can't tell you how to use it. Like I can't tell you when to use it. You have to decide that for example, I want to do some experiment. I want to change something, and then you can create a branch and then mess with it, and then if you don't like it, you can go back. Or if you like it, you can merge it. But I think merge is not here yet because we are still. I think we just finished developing merge because merge is more complicated. So now we don't have the rebase, but you can rebase it. So rebase on this side.
Like the purpose might be to change the schema and experiment how it improves your graph and then
Yeah.
it or not.
Yeah, you can change the schema and the graph, instance graph, which is where the data lives. You can change both as well. It's just like when you create a branch, it's just like you create a new.
No, I know what a branching is. I'm asking why you do it.
Oh yeah. I mean, I can't really like exactly tell you when, but yeah, the reason why would be you want to experiment with things, or maybe you collaborate with someone or something like that. Whatever you can imagine. Okay. Okay, so lesson 1 finished. Actually, very easy, right? So lesson 3. We are not doing everything. So lesson 3. So lesson 3, we are inserting the data. So we have to look at our data. We have our employee CSV and the contact CSV. So what we have to do is to create a new Python file. So data.py. So data.py. So to start with, we have to import stuff, right? So import. So TerminusDB client. Actually, how I do is like I would only import the thing I need. So yeah, again, like Waco is just a silly name at the moment. So I know it sounds stupid, but we try to rename it in the future. So the client it's just like API client that it will communicate with your TerminusDB. So I have to create a client, which I will have to communicate. So let me teach you how to use the client first. So to create a client, you just need to create a Wacom client object with the endpoint in it. So remember the endpoint was, you can look at it from the config.json. It's convenient. Just copy this one, whatever you're using. Let's copy it back to here. So this will create a client that talks to this endpoint. So for those who are using Terminus X, you may also need to use the team equal to that, and then also, so it's also use token equals to true or something like that. I can double check for you later because I think I have it in the, I have it in the model answer script. We'll have this one as well. So, but for those who use locally, you just need to have this because you don't need the API token to log in, so you can just connect like that. And then how can you connect to a database? So we just connect, and then DB equals to the database, the name of the database. Okay, so this is how you connect to a set database. There are also other ways of using a client. You can create a database, you can all this, but we just follow the workflow for this use case today. You can explore a little bit further if you're interested. Yeah, but because we already created a database, we will just connect to it. So here we go. So now we have to get our data, right? So how we gotta do this is to use you can use pandas for those pandas lovers. If you have pandas installed, feel free to use it. Sometimes I use it, but in this example, I use CSV because not everybody have pandas. Not everybody like to have something heavyweight like pandas to do this task. So I will also import CSV. Okay. Oops. Why are you doing this to me? I just want CSV. Okay. Right. So now, what I can do is I need some helpers to help me because I need some things to intermediately store the data when I load things from the CSV. So I would need to have a few dictionaries. So for example, I will have the employee dictionary. Just create as a dictionary. Or employee, I don't know, like you can, yeah. Sometimes if it's dictionary, I like to edit it so I know it's a dictionary, but it's a small script, so it doesn't really matter here, I think. And also, I want to have one that store the relationship between the employee and the manager because I would need to, yeah, I would need to handle that later. There's actually many ways of doing it. I think the way I'm doing it may not be the best one, so just do whatever you like. Some of you, of course, like you're better than me. You can do better stuff, so you don't have to follow it. So I need a manager. So also an address. I think, yeah.
Do you mind going over again what we're trying to do at this stage now?
Oh yeah. So what we're trying to do is to read this CSV. And the other one as well, and to put it into, so we use a Python script to scan through this, and then create some object that we can put in TerminusDB.
Okay, does TerminusDB require a dictionary or like a list of dictionaries?
Yes, we'll come to it in a bit, so yeah. Your question will be answered. So sorry I'm also slow, I'm like just thinking as I go, but if you look at the answer, you already know it. So what we'll do is like, open. Oh, actually, I really want to cheat right now because I really can't remember. What am I doing? Okay, sorry about that. Sometimes, because like I'm still having a jet lag. I'm like, this is very late for me, so I'm just living on coffee right now, and I'm like sometimes doing silly stuff and don't know what I'm saying. Sorry about that. So this is lesson 3, right? Lesson 2, lesson 3, I think. Yeah. So. Yeah, right. So, oh, also I forgot to import the schema. So, yeah, that's what I mean, like I'm too tired. So, we also need to get all the classes that we created from schema. That's why you have the question. I know why, because I forgot something. So, you have to also import everything that we create in schema.py. Reason being, we are creating the instance of these classes. Remember, this is the schema. This is telling that, oh, what the document will look like, right? So the document itself is the instance of them. So that's why we have to import it, right? So after you import that, and after you have these dictionaries, which again, I will cheat by copying this. Just, yeah, I think that is quite complicated when I set it up. So yeah, that's why I said you can do it better than me, like by how to read the CSV and stuff. I'm not doing it very efficiently. So, okay, so I will cheat by just copying the first 3 lines because this is just how you open the CSV, right? So I'm now opening the contact.csv. I think I want to create the address object first. That's why I'm doing this. So I create a bunch of dictionaries which will help me to store the stuff intermediately in Python before I can put things in TerminusDB. So I open the CSV file, just like, and then I use the CSV reader to read the files, which it would give me every single row as, comma separated value would be the list of stuff. So here, I would do a next at the beginning because I want to skip the header. Again, I'm not very efficient in doing that. I'm sure that you will have a better solution for this. So now, for a row in CSV file, for each row, I will have those 4 values, right? I will have, what do I have? I would have employee, and then the contact number, and then the address, and then the postcode. So what am I doing here is that I would break them apart. No, not break them apart, but like store them one by one. So, so the addresses. So that would be their ID, so the employee ID. So that would be the first one, right? So it would be row 0 would be the key of the dictionary, and then I will store their address. So I will store their address. So the address will be an address object, right? So address object will have what would the address object have? Address object will has a street number. So, I can't remember. I can just look at this. What am I thinking? Okay, so I have the street number. So street number, what would be the street number? So the street number will be actually quite tricky. Let me break it down first. So the street number will be so now look at it. So this is 012. So this is this one that I want, right? So one marketplace, I want the 1. So it will be the row 2, and then I break it up to what I want. So be row 2, and then I do a dot split, and then I want the first one. Or something like that. I'm not so sure. I think it will work. So I take the whole address, I split it up with the spaces, and then I take the first one, I think. So look at that again. So like I said, this is more like data handling or data, you just break things up and put them into their place. So street num, street name, or just street here, I think I call it. So again, row 2 split. This time I want to split with the comma, I think. Oh yeah, here I want the comma as well. Sorry about that. No, this one, no, it's a space because it's yeah. So I split it by the comma, and then I want the okay, this is tricky. So maybe I should do it like this. So let's split by the comma first, right? And then I take the first one. Now I split it again, and then I would put them into street num will be the first one of it, and then this one with the second one of it. Okay, so I split it with the comma, and then the first one will be the street number and the street name, and I split it again with the spaces, and then I just take the 2 into 2 different things. I think you can do it like this, right? Like street, something like that. I think you can do it like that. I think. Correct me if I'm wrong. Sometimes I don't know what I'm doing. Okay, so split it and put it into the thing, and then you can also do the town, I think. The town. A row 2, and then this time I want the second one of this, right? So, and then after you have this, you can put it here. You put it like, oh, street num will be street num, right? And then street with street. And then town will be equals to town, or something like that. And then, so you just create a bunch of, so what we're doing here in principle is I just create a bunch of address instance, and then for each instance, they are the subdocuments. And then they will have the properties. And the properties, I get it from the CSV. So this is what I'm doing here. So all these, also I will store them as an object within the dictionary. The key of the dictionary will be the ID of the thing. Okay, so this is how I do it. You can also have the postcode later, but I will put in the postcode later when I read the, what do I have the postcode in here? Sorry, let me see. Oh, the postcode is, yeah, the postcode is the postcode, so it will be the 0, 1, 2, 3, the third thing in the CSV. So I will put the postcode. So what I would do is that address, so this time this is already an address object, so I can do postcode equals to the third object in the row. Something like that. Does it make sense? Or does it not make sense? Well, I'm crazy. I think in the model answer I do it differently, but I hope you get the idea. So it's just like now every value of those, the values in the dictionary are address objects that I created, and later I can put them in the in TerminusDB. So I will actually cheat a little bit and skip all this, because this is just, like I said, it's just data managing, how you can split up all the CSV and then model it like into different objects. But instead of me struggling to like, with my very sleepy brain to make it work, I would just copy this and then I would explain it. I think I explained a little bit as well, but I think this will be better if I explain that in full. So here, so this is what it's supposed to be like. So here you see that for each row, I would break it up into different things. So the contact number is, so I created the contact numbers as well. Okay, so I have the contact number as a dictionary. So I also have always, the key is always the ID of the employee. And I will store them, and I also break up the street address. And then I would create an address object like I did here, and I just put everything together like that. So these are the address instances. They are the address object that we created. We just store them with the key being the ID of the employee. I store them in the dictionary, which we will be putting it in later. Haven't done it yet. So same with the employee CSV. I read all the information there, and then. So this is a bit tricky, the team, because it's it's supposed to be like this, right? So this one, if I don't do it like that, it should be team.it or team.marketing, right? So, but this needs to be in the code. So that's why I use eval to do it like that. So that's why it's easier to just call it IT and marketing, because I can just read it and I just lowercase and then do an eval with it. But in enum, you should do it like team.id or team.marketing. That's why I use the eval there. So also I artificially create an ID for it. Is how I hard coded it. I read the raw 0 will be 001, 002, right? So I just created employee/001, employee/002. That's how I create a unique ID for them. It's not the best way to generate. I think the best would be make TerminusDB creative for you, but I just want to make it simple and not mess with extra features. So And then address, I put the address in, I put the addresses in. So you can see that, remember the address, all the values in the address dictionary are the address object we created, right? So now I just put it in. So a property, so this address property, right? This address property of the employee would be an address object, okay? Does that make sense? And then contact number team will be the team that we create with eval here. Okay.
So how do you make sure that
Huh?
how the reference, the construct
Yes, it's because this address row 0, remember this is the, so addresses become a dictionary with the key that's 001, 002, 003, 004. The values will be these address objects that we created, okay? So we just put that in here. I temporarily store them in dictionary because I have 2 CSV to read. That's why I temporarily store them in dictionary. But then I can put it, but then I get it back from the dictionary and put it there as a property of the employees. So when you see how I do the manager, maybe it's clearer. Because like manager, right now I only store like a mapping. So it's just a mapping from one ID to another ID right now. So we haven't put the manager yet, actually. So how we put the manager in is to use this. So I get all the mappings from, because I want to read the whole CSV and understand all the mapping before I put it there. Because for example, if I haven't created a manager yet, right? So I don't have a manager to put it in here, which is bad. So that's why I store the mapping of the manager first, and then later I can get back. So I use the employee ID of the employee to get back the employee object, and I can just dot manager. So if you don't want to do it this way, you can just like do it similar to this. You can just, use the employees and then the ID and then dot address equals to address and then this one.
Sorry, Mayor.
Yes.
How do you handle the directional relationship between, for example, address and employee? If you place the information of the address on the employee entity, if you place the employee information on the address entity, okay, how you can relation between them if you create first all the address, then all the employees?
So here, how we design it is that addresses are subdocuments. So they have to live inside a employee. Once they go into the TerminusDB, the addresses need to live inside the employee's object. They can't live by themselves. If you want the address to be able to live by themselves, you have to create it as a document, not as a document. Yeah, so if you want to just link the address and the employees, so you can have a bunch of addresses floating around. You can also set what their owner is by linking them to the employee, but then they have to become their own document. But in this case, because we make the address a subdocument or an object, so subdocument doesn't have an ID, right? It needs to live within a document. So you can imagine all this stuff. Actually, you don't need to have an address subdocument. If you don't want to, you can just have a bunch of these things, right? You can just have address, street number, address name, address, street name, all the stuff, right? You can just.
Sorry, the problem is remains because if you have the address information should be contained inside the employee.
Yeah.
The employee information should be contained inside of the address because you need to normalize data in order to get, I don't know, some performance, for example. How can you fill the employer's the address stuff without having created first the address part, the employee part?
I don't quite get your question. So are you talking about exactly this use case, or like imagine that we don't have the employee yet?
No, it's another use case.
Hmm?
We can talk later.
Yeah, maybe that's easier when we talk one-to-one. So in this case, every employee has to have an address, and the address has to be living inside an employee when it got created in the database. In Python, it's fine. In Python, whenever Python allows, you can do it. But because now we only put it in Python, we haven't put it in TerminusDB yet. So it kind of is just that the limit is your Python knowledge, basically, or what Python allows you to do. So So yeah, now it comes to the last bit. How we can put all these, so we have a bunch of objects. So we have a bunch of employees documents that live inside this dictionary. But how can I put that in a TerminusDB? So this is how. So the last thing we have to do is so we already connected, so we can already use this client. So how can I use this client? So what I can do is to insert documents. So what should I insert? I should insert all these employees back, right? So I think I just call the employees dot values and then use it as a list, something like that, I think. I'm not so sure, but I would double check. So I just get all the employees from the dictionary and put it into TerminusDB. Yeah, something like that. And then you can also add the commit message as well. So I'll just copy this. Whoop. Yeah. So I just grab all these employee objects, 4 of them. You don't need the address object because it already, so remember we already put them in the employees object, right? And they should not be living by themselves. They should always live inside the employee object. So it's okay, we don't have to insert them separately. We only need to insert the employees object. It will include the address already. So get all of them, put them in a list, and then put them using the insert document, and then you can add a commit message to make it nicer, okay? Adding 4 employees. So in theory, this one should work. So let's test it out. Okay, so let's test it out. Okay, so this time I just run the Python script, so Python insert data.py, and then doesn't have an error message, good sign, but we don't know. So let's have a look at the log. Right, oh, so we have another commit, which is good. So I've done something, at least. But is it correct? We don't know, so how are we gonna do it? So TerminusDB, and then all docs. This is how we do it, but look at all the documents. So, wow, a lot of things. So these are the 4 employees that we have inserted. So if you look at it, address will be, this is the address. So you can see that even though address has an ID, TerminusDB won't allow it to be its own thing. So it always needs to live inside the employee object here, okay? So, yeah. So this is how it looks like inside TerminusDB. So this is in JSON RD format. So you can also, if you can write this, you can insert it directly, but for me, myself, I find it easier to write a script like this. Like, this is already complicated enough, right? So if you also have to construct a JSON like this, then I would be, no, I don't want to do that. So yeah.
So both the employee and the address are documents?
Yeah, the employee is a document, address a subdocument. Subdocument is object which doesn't have an ID. Even though you can see that, oh, no, but you were lying because there's an ID here. But this one is the ID that TerminusDB generate for it to use internally. You should not be able to give it an ID. Yeah, it should not be visible to you actually, but we just print everything. So it just but it is used internally, but not for your use. So it shouldn't have an ID. That's why, yeah. And also, if you look at it, it's very weird, right? It has the employee address and then address like that. And then that's how you see the ID. You know this is a document because it lives within another object, which is employee for 004, right?
Sorry, what was the command to see this output?
Hmm?
What was the command?
Command is all docs. So this one, all docs. So in case you forgot, you can always use -- help. It will give you all the command options. Yeah. So, okay, now we have everything. So fun bit, we gotta do query using triples. So now it's lesson 7. So lesson 7, we gotta do some query with what we have learned. So. So again, lesson 7, we will create a new file, new Python file. So Marco query.py. Oh, Okay, so this time we need the client, of course, so let's do the same thing from, can't spell it, TerminusDB client, import, again, the Waco client. This time we also need the query. So we have created the Waco query, which we now mainly use for queries. So Waco query. Also, we noticed that we have to type this a lot, so what I'll do is just shorten it as WQ, just like pandas, right? PD or NumPy and NP, you know. Yeah, why not? Just to make it shorter. So this is what I'm getting myself ready to make queries. So how Waco query works is that you would have to, so Waco query, first of all, warning, Waco query is very complicated. Yes, because today we just learned triple. If you can do the query today, it's really good because, you know, you can already use what you learn and make some queries and make some logical reasoning. But if you really want to dive it down, it will require some practice. Even for me, sometimes I have to, you know, wrap my head around and think, oh, how can I query it? Things like that. So, but we'll give it a try. So, again, we need a client, so let's do that. We can actually copy and paste what we did. Especially for those of you connected to Terminus X, it's quite complicated, so just copy it if I were you. So just do the same thing, connect to a database as well. So we just do this. Okay. Similar to what we did before, nothing to add here. So now we create a query object. For me, whenever I do the query, I would first want to look at least some of the things, not everything, but like if you can look at everything, that's good because you have an idea how it looks like. But sometimes the database is too big, then maybe you have to not query everything. But I'll show you how to query everything. So you can make a query by using WQ. Well, or you can type the whole thing, but I just shorten it as WQ. So it just needs to be an object itself, and then you can start querying things. Like for example, you can do like triple, and then ask for triple or something. We'll go into it later. Right now, I just want to do star, which star is just like star in SQL. It gives you everything, but use it carefully because if your database is big, this will probably have consequences. So right now, database is not big, so we can do that. So let's try to see what's everything as triple inside the database. So it's not like all docs. All docs, you can see all the documents as documents, right? They are very nicely presented to you in the JSON LD format as documents. But now we also look at it as a JSON LD, but as triples. So it's going to be very interesting. So this is our query, but we have to execute it. So how we do it is to do .execute, and then put a client in it. Oh, actually, this will give you the result. So let's just print it out to see what's happening. Okay, scary stuff. Okay. Oh, actually, what is better is to use preprint because it would be messy. So, okay, I love using preprint. So, pp.pprint. So let's print everything within the database as triples. Let's see what happens. So go back to our beloved terminal. So now what I want to do is to do the query thing. What was that called again? Oh, Waco query. Yes. Whoa, what's this? Look at all this. Wow, it's a very, very big. Well, even though our database was small, like it's only 4 objects, it contains a lot of triple in it. Right? It's wow, all this stuff. What are these? So let's have a deeper look inside, right? So let's pick something that we kind of understand. So let's look at here we have so we have, what does this mean? So we have an object, okay? So, oh, by the way, for all this query, when you get a result, so it's kind of like API getting the result, but your result will be stored in bindings. So we just look at bindings most of the time. So we have object, predicate, and subject because remember all triples, they are object, predicates, and subjects, right? Well, the order is a little bit different here, but doesn't matter. Order doesn't matter in a dictionary. So, unless it's order thing, but order doesn't matter. So we have object, predicate, subject. So there's these three things. So these are all the triples, every triples that you can find in our instance graph. You can also get it from the schema graph if you want to, but we are not doing it right now. We only look at the instance graph. So these are all the instance, all the documents, but as triples. That's how it looks like. So very interesting, right? You have something that is employee/01, so that's the subject, and then the type of it is an employee. So it tells you something. It tells you some information about this object. Employee/01, it's an employee. That's what it's saying. I'm trying to translate it. So another thing, let's look at this. Whoop. So employee/01, schema, contact number, and then, object is another dictionary. It's saying it's a XSD string, and then it's a string. The value is a string. So it's saying that employee01 has a property called contact number, which is a string. The value is that one. Okay, so this is how it looks like within TerminusDB as triples. So this is how a knowledge graph looks like, actually. Yes?
So where does the concept of ranges come into play?
Yes, good question. So if you look at this, so this contact number, right? This contact number, what do you think the range is? Huh?
String.
The string, yes, XSD string is the range. And the domain is the employee01. Okay? This,
They got those from the typing?
huh?
They got those from the typing?
Because of,
It got those XSD string from the typing?
yes. So this XSD string actually is telling you that it's actually a string. Because everything is a string here, right? I just print everything out, they're all strings. But it means that that value there is not a number, it's a string. You know, even though like I don't have the bracket, right? Imagine it's only this 113367, right? It can be an integer, it can be a string. So because the type is saying XSD string is a string. That's how you declare a type. So that's why you don't have the problem of like sometimes, you know, Excel thought that if you import a CSV in Excel, right, sometimes it thought that, oh, it's an integer, but actually it's a string. So then you lose all these trailing zeros and stuff, right? So it won't happen here because we have the type. There's no ambiguity. There's no guessing. That thing happened in Excel because Excel was guessing. But in here, there's no guessing. So this is how it looks like. And by using this knowledge, we can ask some questions. So in lesson 7, we have made some assumption. We have an imaginary situation that we want to contact someone in the company. So let's take this out. It's scary. We take this out. So okay. So let's think that we want to. So instead of looking at these two CSV, we want to find the contact information of Darcy, right? So we only know the name of Darcy because we are not working in the company. We don't have access of this spreadsheet or something. We just know that, I want to ask a question. I want to have the contact number of this person. How can I do that? By asking the database. So let's ask the database. So let's make a query. So query equals to, before that, what I do is like, because remember, every string we have to declare the type, right? Otherwise, TerminusDB don't know that it's a string. Well, for Darcy's case, the name is obviously a string, but because we don't guess things, we always have to declare the type. So what I do is that I create this thing called, Darcy. I will have to declare it as, say, Wacko string. So this is how I declare it. It's a string. And then it's, what the name of Darcy? Oh, sorry. Where is it? Yeah, here. This is Darcy's full name. I will just copy it and then put it. It would be nice if I can just do like a fussy search or anybody who called Darcy, but well, we are not stepping into that yet. So let's just look at it. If I know the full name of Darcy, I want to find her contact detail. So before that, I have to declare that it's not a normal string. It's a Wacko string. is a string type that we use in TerminusDB, okay? So now we really make the query. Query equals to wq dot triple. So what question should I ask? Okay, so I have a person, right? So we have to make a variable in the query because we don't know the ID of Darcy, right? I don't know what's Darcy's ID within the database, so I will just ask someone that I know, a person. That name, so I have to do schema, I think. Schema like that. Name, I will double check. So I have to say that, oh, there's a person, name is Darcy. Oh, not this one, but the Wacko string. The other way won't work because it doesn't know that it's a Wacko string. So this person, so this query, if I run it, it will give me the ID of Darcy. But it's not helpful because I want to know the contact number, right? So I have to add another one. Add some condition, add another triple. So the other triple will be the same person, right? Will have a contact number. And then I also don't know the contact number, so phone number maybe, phone number. Okay, give me the number.
I think you have a typo on line 12, where you have the name. Is it supposed to be a name?
Like that, right? I can't remember actually. Let me.
I mean, at the end, like after the M.
Oh, like this?
Like, yeah.
Oh, yeah, like that. Yeah. Actually, I would double check whether I have the type because I really can't remember whether I need to add or not. So let me double check. Yeah, I need to add. So okay, so it should work like that. Sometimes I also have to reference it back because this syntax is complex. But I'm showing you the basic of the basic, so you can do it deeper when you want to yourself. So, okay, so this is how I make a very simple query, is that I ask questions, and then I will get the answer back as variables. Okay, so now I want to know the phone number is a variable. Well, I also accidentally got the ID, but, well, I don't mind. So when I have the query, I have to get the result from the query. So result equals to query dot execute. Put the client in here. Remember to put the client. So now I should have a result back, and I can print it out actually. Let's print it out and see what happens. You know, yeah, we can debug as we go. So let's do this again, right? Clear it up and then do this and. Oh, I doesn't got anything. I must have a typo or something. Wait a second, let me fix it. Oh yeah, I spelled it wrong or something. Don't worry, I can just copy this. Yeah, that's why it's quite difficult because for someone like me, oh no, not here. Yeah, for someone like me that make typos a lot, then it's quite challenging because it's difficult to debug. Yeah, I got it. Yeah, I got it. Okay, let's replace this. Yeah. I just spelled something wrong. So yeah, let's try again. So yes, I got something back. I asked the right question this time. So they are the bindings. So this time we have the bindings, and so we have the person. So actually, I accidentally also got the ID, but I don't care. What's important is that I have the phone number, which is this one here. Right? So you can peel everything off like an onion. You can peel it off and find the answer here. But I think I already did in the code in the model answer here. So yep, if I found it, then I just go to the bindings, get it, and then get the phone number and the value and stuff. Otherwise, I can't find anything. So this is a very nice Python code. I just paste it here. So it'll print out the result for me. Thank you. Yeah, so this time if I run it, it will be very nicely presented to me. Right. Yes, now I have the contact number. Good. So this is how you can query by using triple. There are a simpler way to do it. It's called query document. Then you can get all the information about Darcy actually. But well, yeah. this is more fun, right? It's more fun to just make triple and stuff. I love it. So now ask a more difficult question, which I think is better to answer with triple than query documents, is that now imagine Darcy is on holiday and I really need to talk to someone in a company about something. So maybe I should talk to Darcy's manager, right? So how can I do that? Because, well, imagine if you are making SQL query, you will have to first find the manager of Darcy and then find the phone number of Darcy's manager. But in Waco, we can just traverse the graph instead of joining it back using the key, you know. Remember the employee ID as the primary key, and then you have to join back together to find who is the manager of who. We can just traverse the graph and use triple to find the answer. So here's how we do it. So this time, Darcy's on holiday, so we make another query. So query is, so this time, so I know someone who's called Darcy, so let's get this again, right? But this time, instead of getting Darcy's number, I want to get who's Darcy's manager. So I do the similar thing, but this time I want manager. So I want manager, and this time I should call the manager a manager, because I don't even know the name of the manager, okay? I don't know anything about the company, imagine. So I would have, I have two variables here so far. I will have a person, which is Darcy, but I don't know the ID of Darcy, and the ID of Darcy's manager. But it's not good enough because I know the ID, but I don't know what's the name and the contact number of this person, so of the manager. So what I'm going to do is to also get the phone number of Darcy's manager. So it's very similar to what we did here. So we just recycled code. So here, instead of person, I want manager. And then, also, maybe I should have the name as well, just to be polite and be able to call the person's name on the phone number. So I want to have the manager's name. So instead of phone number, maybe I should be manager name. So something like that. So if I run this query, I should be able to get Darcy's ID, which is person. I should be able to get the manager's ID, which is manager. I should be able to get the phone number of the manager and the name of the manager, okay? So again, I can do result.execute. And I put the client in it. Remember to put the client in it. Oh, result equals to, sorry, query dot, yeah, result. Yeah. Because I'm merging result and query together now. I'm like, so crazy. Okay, so let's print the binding of it. Let's try to just imagine it works and print the binding of it to see whether we can see something. It's called bindings, yes. Let's see if it works. So, oh, manager. This one? Yeah. I love this like live debugging. Yeah. I wish my robot duck can do the same thing. It will tell me, you have a bug. Okay. Right. Let's see. Okay, so ignore what we did before. So we have the binding, which I have a manager's ID. Yes. A manager's name is a string. It's called Destiny. Oh, good. So we have ID for the person, which is Darcy, and we have the phone number of Destiny this time. So we can probably print it out like before to make it nicer. So if you copy the code from the model answer, it should print out very nicely for you. Yeah. Here, copy the whole thing and paste it the whole thing. And then it should work. Let's see. Yes, so now I have the manager's name and the manager's contact number. So this is a taste of how you can make use of Waco query to actually, you have when you see how I do it, right? Of course, I think about that before, but this is exactly my thought process when I'm creating this query. I'm like asking question. I'm asking, oh, what do I want to know? And then making variables to link up all these informations, just like linking triples to build a world. But instead of building the world for sure, I have variables in it. But by answering, so what happened is that TerminusDB will take this query and then put it, so you have some variables, you have a hole in it. But it's fine, it's okay. You just put this on top of the graph, and then the answer will shine through this hole and come back to you as an answer. So this is very efficient. Imagine you have a big company and you have to do a join with like using the table and join it back to itself again. Or maybe you have to also join the contact table together and all this stuff to get this answer, which is crazy. Now you just need to like think of how I can get the answer by using the variables and go through the graph, and then you can get the answer. So this is very different from what we know.
You run applications like counting, limiting, skipping, grouping by.
Yes, exactly. We also have that in Waco, but that's more complicated. And if you're interested, you can have a look at the documentation. It's available there. There's the count. If you look at the Waco documentation on the website, actually, yeah, we're still building it, but yeah, we do have the counts, we do have the group by and all the stuff, but that will be more complicated. That's very scary for me to do those things, but it's available. That's all I can tell you. Yes.
Can you talk to us about the syntax in the triple method? Why is there a V colon sometimes? What's the at schema? Can you just define those for us?
Yes, the V colon actually is a variable. So you see that here, all the V colon will get the answer from at the binding. You see all the bindings is giving me the manager name. So these are the variables we created by using the V colon here. So that's the answer that we will get back. We can also use this to link up different questions, different triples. That's how we do it. Also, for the schema thing, this is just saying that it's a property. So it's a property from the schema. So it's just saying that, oh, what is this manager? Because manager is a name that's very ambiguous, right? But a schema just means that, oh, look it up. Look it up at the schema. So yeah, it's a property. It's declared in the schema. Look at it. So that's why there's this. So
are there others besides those? There's V, there's the schema, are there others that we should be looking at?
there are. I have to look it up. I'm not so sure, but if you look at this star thing before, right? So all you can see are the schema. So usually the thing we start with at is some keyword that we use internally in TerminusDB. So there are also other stuff like RDF. So RDF is declared because we are knowledge graph, right? So it's a hidden feature. So it's every graph hidden. There's a RDF document that kind of store all the default things for the graph, so all the settings for the graph. So this is RDF type. It's just saying that it's a type keyword that is declared in the RDF file internally, so something like that. So also XSD is a standard type or something like that. So yeah, there are a few of these things, but yeah, it's more advanced, I would say, if you want to dive deeper. So yeah. Yes.
Can you describe in some detail how this might be different than, say, Mongo or NoSQL, where you're again storing documents and maybe you have reference objects within the documents? How does TerminusDB or graph database work differently than, say, NoSQL in terms of?
Yeah.
What would be the difference?
So NoSQL,
And
well.
why would you use one over the other?
Yeah, NoSQL is because the thing is like how we do this triple thing is because NoSQL is more similar to the document interface that we created.
Yeah.
This is what is more unique to knowledge graph that we are looking at the end here. So for document, that's why we have both available, because this is very scary. Sure, unless you are from an academic background that you deal with semantic knowledge graph all the time, then you're very fluent with it, then this is no problem. But most people can can work with what the document interface or like the syntax closer to NoSQL much easier because it's very structured in a way that is, oh, these are the object and this is the property of the object. So it's more like a object-oriented programming, the object in object-oriented programming. So at the beginning, when we have TerminusDB, so we only have this. So it's a knowledge graph. So everything is a knowledge graph. So internally it works like that. For someone who works with it, need to understand this. And then later we discovered that it's too limiting. So we created a document interface that you could actually use both syntax to work with stuff. So that's why today we are trying to use both. We try a little bit of the document interface at the beginning. It's simpler. It's get us to work so faster. You can see we already have a simple knowledge graph very quickly, within an hour or so. But then at the end, we try to apply what we learned today, but it takes practice to be very fluent with it. So we kind of start to use a little bit of triple, understanding how triple works and stuff. How triple works and stuff. God, I hope I don't. Okay, yeah. So you can see that TerminusDB can work with both. So I think it's the advantage of you can use both. So yeah. Yes.
If you have a more dense knowledge graph, okay, it's made up of multiple kind of connection, multiple kind of relation, multiple kind of objects belong to different labels, different maybe. What are the algorithms that have been already implemented in terms of traversing the graph? I'm thinking about the A-star, graded cursor, something like this.
Yeah, you mean the
Using
graph
for this
algorithm.
kind of logic for searching for nodes.
So you're talking about the graph algorithms, right? Like, how many neighbors?
Exactly, yeah.
Those are not available yet, I can tell you. Because I know it's available in new project, but that actually, you just need to, it could be something that's just add on, because our core team, well, we are a small team, the core team basically work on the inner working of this, try to optimize it, build the foundation. I would say this is the foundation. All those things that you mentioned, the graph algorithm and stuff, are the stuff that is, you can add it on top. Those takes time to implement, but it's not as difficult as because our most effort now is to polish this, to make this foundation work well. And then when we grow, when the company grow, when the team grow, then we can add those algorithms. You just need someone who just specializes in writing those algorithms, put it on top. I won't say it's not difficult, but it's just it's not the main focus for us right now. So, well, hopefully in the future we have those. So, yeah. Yes.
Sorry, I didn't want to know. But, so typically when you talk about a graph database, or at least as a data science way of learning about it, is nodes and edges, and can you help us understand how triples equate to nodes and edges in the way that you would analyze a graph database?
Yeah, I would say that you can think. So, yeah, I also have the same question when I started to use the triple and all this stuff to understand semantic knowledge graph. Sometimes it seems that we are talking about two different languages because, triple is so vague. You can also describe the property and stuff. But if you think about it, right, if we can look at it as the document interface. So if we look at the documents, you can imagine documents as nodes, right? And then you can imagine the object properties are the edges that we talk about. But then you will be like, what about the data type properties? Then it's a bit complicated. Then you have to also consider the XSD types, the literal types as also nodes, which doesn't feel correct. So if it's a graph that if you ignore all the data types, properties, if you only look at object properties, it's like what you said. They're objects, they're nodes, and they are the links, which are the edges. But if you include data type properties, it's more. And then it doesn't seem that it aligns. Mm-hmm. Does it make sense?
Yeah. That helps.
Any more questions? I don't know about the time. What time does this tutorial end? Double check. Yeah, sorry, I'm so bad with the time. I think we still have half an hour. So I would say that the rest of the time you can feel free to play around with the other lessons. Or if you have more questions and you want to ask me one-to-one, or yeah, then feel free to do so. I think I will leave this podium, but I would come around, and then you can play around with stuff. You can ask me questions in a more, one-to-one, so I can answer it better, because sometimes I can't hear you or something. So yeah, the rest of the time is yours. Do whatever you like, or if you have other plans, you want to leave early, it's fine. You're welcome to do that as well. But I will stay here and answer your questions, okay? So, I forgot the closing. So let me quickly do the closing, and then you can do whatever you like, okay? So just a few slides, just to close it. So just to summarize what we have learned. So we have learned a few things. We have learned that what is knowledge graph. We have learned that knowledge graph model, there's something that they can do, and that's how they work different from the relational database. And there's lots of good questions about how they compare. There's like what the advantage of thinking things like the scary triples. Also, how we have already achieved how we can model data from 2Ds with the spreadsheets or CSVs into a graph. And then we also try to play with triple, try to use triple to ask questions and make queries. So I think we have achieved quite a lot today, so you should be proud to yourself. If you have more questions, this is how to find a team. We have Discord. If you use Discord, join that, and my colleagues, they are more knowledgeable than me. They can answer your questions, sometimes specific questions about the internals of the database, or questions about JavaScript, how to use the JavaScript client, all that stuff. Please come and talk to us. Love to talk to you. And I think that's it. So do whatever you like, and I will stay here and answer your questions, okay? Yeah. Thank you.